In this problem, we have to assume that all variables represent positive real numbers. And we're asked to simplify the square root of 50y to the 6th. Notice inside the radical, I have 50 times y to the 6th. So I'm going to have to use the product rule of radicals that says the nth root of a times b equals the nth root of a times the nth root of b. Notice this works with products, things that are multiplied together. It wouldn't work if I had a plus b or a minus b. So in our case, what number is up here on the radical that we're too efficient to write? We have an index in our case of 2. So n equals 2. So we can write the product rule of radicals for n equals 2 as the square root of a times b is the square root of a times the square root of b. So I'm going to use that in my problem. I have a product here, so I'm going to write it as the square root of 50 times the square root of y to the 6th. Now we need to simplify the square root of 50. Is 50 a perfect square? No. So let's factor 50. There's lots of different ways of doing it. I'm just going to pick 5 times 10. Are either of those perfect squares? No. So 5 is a prime factor, so let's factor 10. That is 5 times 2. So another way of writing 50 is 5 times 5 is 25 times 2. So I'm going to use the product property again, and the square root of 50 I'm going to write as the square root of 25 times the square root of 2, because 25 times 2 is 50, times the square root of y to the 6th. Now, what is the square root of 25? It's a perfect square, so the square root of 25 is 5. Can I simplify the square root of 2? No, I have to leave 2 inside the radical, so I'm going to have the square root of 2. I left a little space, so I can write something else in a minute. And now I have to figure out what is the square root of y to the 6th. I'm going to use the shortcut method for figuring this out. And the shortcut method uses the fact that the index here is a2 because it's a square root. And what we do is we divide the index 2 into the exponent 6. 2 goes into 6 3 times. 3 times 2 is 6. Is there any remainder? No. The 3 is the exponent on the variable outside. So I'm going to have y cubed outside. And then the 0 is the exponent on the y's inside. So I have no y's left inside my square root. So what is my answer? 5y cubed times the square root of 2.